Hello, and welcome to this overview to data and visualization. Data visualization is one of the fastest growing areas in computing today. In fact, the Forbes magazine recently highlighted the data scientist as among the top 10 most promising jobs of 2015. A data scientist is similar to a business or a data analyst role, but usually with a particular focus on the use of computer science and applications to collect, analyze, and visualize data. Data scientists are skilled in not only finding the best ways to analyze data, but to also pick the right problems to solve. Data scientists are not only professionals involved in data and visualizations. In fact, many careers and roles today require critical thinking and an ability to analyze, understand, and communicate findings from data analysis. So why are data scientists listed as having such promising careers? And why is data and visualization fast becoming a critical part to many careers today? We live in an information-rich society and we're surrounded by data. But many fields today, from health to business to education, all use data to answer some really big and small questions. For example, what are Google search patterns and demographics of people seeking health advice on the internet? How can we use data to determine foods that help us live longer, healthier, and happier lives? What impact will rising sea levels and increased temperatures have on our society and environment? However, data is also presented to us in everyday lives as information in a myriad of interesting, useful, practical, and/or innovative ways. We draw on data to answer everyday questions that we may encounter, or to help us in particular situations. For example, what is the best way to get to the shopping centre? What should I wear today? And will I need a raincoat? In what areas are bushfires currently occurring, and is my house in danger? Let's have a look at some examples of how data is being used and visualized in different contexts. In this video here, we have an example from the field of wearable technologies. This example video is about the Fitbit technology. It's a wearable wristband that can be accompanied by a mobile app that collects data about daily activities, such as movement through tracking GPS coordinates, fitness levels, and health. It also allows users to add data, such as food eaten. But there are some fascinating examples of people also taking real data and using computer science to present interesting visualizations. For example, what we see here in this video is data taken from flight path patterns being represented as an evolving simulation. By collecting and visualizing flight data, the creator is able to provide not only an interesting visualization, but illuminate the patterns of human movement. Data is also collected and analyzed to solve problems. One example here from the University of Adelaide is that computer scientists are currently working with conservationists to be able to develop and use very small tracking collar devices to put on wombats. Originally, the conservationists would track wombats manually by searching and recording or by hunting for them using sensor devices. Instead, by putting a tracking device on the wombat, they are able to receive real-time information collected as GPS data from their devices about location and movement. This data can be presented visually to the conservationists through the use of tables, mapping, or other means. As you can see, the collection, analysis, and presentation of data has become very important to a number of different fields today. What's common across these examples? There are three main aspects: the collection of data, the analysis, and the presentation of the data. When creating these visualizations, people need to deeply consider these processes and the way that the data can be manipulated. Collecting the right data, analyzing the data, and finding useful and meaningful ways to visualize data are all critical. In this stream, we will focus on these aspects by unpacking each, but also exploring the relationship of computer science processes to each of these stages.